Okay, I'm going to show you how to partition a line segment in iXL B.10. This goes right along with the notes that we took in class on both Thursday and Friday. So this should not be anything new when you go to look at this lesson. So when I'm looking at this first question here, they give me a graph. Some of the questions will give you graphs. Some of the questions will just give you points. But we're going to do this exactly the same way that we were doing this in class. So first I'm going to look at, okay, they've given me a ratio from DF to EF, and that point F lies somewhere on the line. So we know point F is somewhere between D and E. And all that we know about point F is that it partitions the line to a 1:2 ratio. And that's important because that's going to help us find that exact location of point F. And since it's DF and then EF, we know that that's a part to part, just like we were discussing in class. So since this is a part, DF is a part, and since EF is a part, I need to write my ratio as part to whole. So if there's one part here and two parts here, that means there's three parts altogether. So the whole is represented by 3. So my ratio, my K value, is going to be 1:3. The first part, which is DF, over the whole, which 1 + 2 gives me 3. So I know my K is 1:3. And so what I would then do is I would find my ordered pair for D, and I would find my ordered pair for E. And when I look at point D is at 3,18. And when I look at point E is at 15,6. And then I need to find the point that it partitions for point F in a 1:2 ratio. And I'm going to do this first example without the formula. We learned 2 different ways in class last week. We learned kind of looking for that horizontal component and then that vertical component. And then we also learned using kind of a specific formula. And remember in your notes, we had written, the steps were written out. And so you would go back to those steps. So the first thing I'm going to do is find the horizontal component. The horizontal component is how far apart the x's are. So remember, you take the second x and you subtract the first x to get that horizontal component. And if I'm going to take the second x, that is 15, minus the first x, that is 3. And that's going to give me the horizontal component. And the horizontal component, 15 minus 3, is 12. Now, once you find that horizontal component, just like we were doing in class last week, this is how we were doing it on Thursday, you take that horizontal component, 12, and you multiply it to that fraction we created, the part to whole, the 1/3. So we're going to take 12, and we're going to multiply 12 by 1/3. And when I multiply 12 by 1/3, I get 4. And then if you were looking back at the notes that we took on Thursday, it then tells you to add the first x value back in. And remember, when we're looking at this, this is the first point, this is the second point, and I know that because D goes first, E goes second. So point D is first, E is second. So you add the x value of the first point, which is 3, and you get 7. So if I was writing an ordered pair, the first part of my ordered pair would be at 7. Then we need to find the vertical component. I'll change colors just like I did in class here. So the vertical component. And when I'm looking for the vertical component, that formula is the second y minus the first y. And the second y is 6, and the first y is 18. And 6 minus 18, this time I get -12. So I have -12. And if you're looking back at your notes, after you've found that vertical component, you're going to multiply that vertical component by your ratio, which we found to be 1/3. And -12 times 1/3 is -4. And then you add it back to the first y. And the first y value is, my first y value is right here, the 18. I'm going to add that back to 18. -4 plus 18 is 14. So I have 7, 14. that is where point F is partitioning my line. So I would go to 7, 14, and I would use the tools in iXL to graph that point. So when I go up, oops, I lost my place here. 7, 14 is right here. I have partitioned my line segment and I am finished. So that is how you partition the line segment. Now this one I am going to do using the formula that we learned in class, which is the same thing I just did. So if you prefer to just find the horizontal component, multiply it by your fraction, and then add the first value back in, that's fine. The formula that we learned in class on Friday is doing exactly that same thing. This was the formula, K times the second x minus the first x, and that's what we were just doing. We were taking the second x minus the first x, multiplying it by K, which is our fraction, and then you add back in the first x. That's the horizontal part. And then the vertical part is K times the second y minus the first y. And then you add back in the first y. And so that's our vertical part to find the ordered pair that we're looking for. So when I'm reading these instructions, it says EG, FG, and it tells me that point G is what's dividing my line up. It's what's partitioning my line. So I know this is part to part. Remember, you also need to pay attention to if they give you part to whole, because if they already give you part to whole, then you need to make sure that you just use the fraction that you're given. But again, I have part to part, so it's 3 to 1, which means there's 4 parts total. So if there's 4 parts total, I am going to take the first part, 3, and put it over the total parts, which is 4. So I know that my K is 3/4. So then I'm going to use my formula. Again, you're doing the same thing we were just doing on the last problem, except for it's a little more formal in the formula. So I'm going to take my second x, and when I look at this, this is my first point, this is my second point. So my second x is -4. And I'm going to subtract my first x, which is -16. But when you subtract a negative, it becomes a plus. And then I'm going to add back in the first x, and the first x is -16. And again, that double sign, if you want to leave it, it's not a problem, but you can just make it -16 because that positive and negative makes the subtraction. And then the rest of my formula will be for my vertical part. And again, I use the same value for K, so that's 3/4. And then it's my second y minus my first y. Well, this time my second y is 0. Subtract my first y is -12. So minus -12. Again, when we subtract a negative, it becomes +12. And then we're going to add back in the first y, and the first y is -12. And then I can close my parentheses. So by doing this, I am going to get the ordered pair where that point lies to partition the line segment. So just like we were doing in class on Friday, I'm going to do the blue problem separate from the red problem. And for the blue problem, we're going to start right here first. We're going to add -4 plus 16, which gives me 12. So then I end up with 3/4 times 12 minus 16. And I'm going to stay away from the red for a moment. And so like we talked about in class, if you have one of the calculators that you should have for class, you can use that ABC button and use your fraction button. So you could do 3ABC4 times 12 and hit the equal button. And when you do that, you should get 9, or find 3/4 of 12, which to do that, we can divide the denominator in 4 into 12, which 4 goes into 12 3 times, and then multiply 3 times 3 and get 9. So this becomes 9 subtract 16. 9 subtract 16 is -7. That is my first value for my point where the partitioning point is. And then I'm going to come over and let me switch colors here. I'm going to do the vertical component and find the y value. So again, you're going to start with what's in parentheses. 0 plus 12 is 12. So this is 3/4 times 12. Look at that. It's the same thing we had for the other one. And then I'm going to, instead of plus -12, I'll just go ahead and write it as that subtract 12. We just did 3/4 of 12. We said 3/4 of 12 was 9, subtract 12. And 9 subtract 12 is -3. So I end up at -7, -3. And so I would then go into iXL and I would type my answer, -7, and then -3. And once I have that, I can submit it and go on to my next question. So the only thing you do still need to pay attention for is looking at that ratio, and just make sure if you notice that they give you, like if it starts with line CD, and if the second part of the ratio says CD, just like the ones we looked at in class, they're already giving you part to whole, and you can go straight to the fraction. And that does happen occasionally. It's not happening in this problem, and I don't want to redo one we've already looked at. Let me go up. I can go up a level here, see if I see. This one is still part to part, but you may run into that on the iXL. And if you do, just be very careful of that. But that's what you are doing on B.10. And hopefully this helps you a little bit if you're stuck.